Now, ladies and gentlemen, this chart should be all I need to show you to deal with negative exponents. I should be able to stop right now. The next page in your book asks you to apply all 7 exponent laws. There's a question on that page that no matter how many times I talk about this chart, no kid can do. So I have started adding to this chart and trying to expand the definition of negative exponents. And no matter how many times I expand that definition, when the kids get to that question on the next page, they still say, I don't know what to do. But I soldier onwards, and I will try again. So we have explained this, yes? Because, of course, a negative exponent makes no sense, right? You cannot possibly take a base, 2, and multiply it by itself negatively. It makes no sense. You cannot do it. Regular exponents, positive exponents, make perfect sense, right? You don't need to write this down, but a positive exponent makes easy sense. 2 squared. There's 2, yes? Squared. There's 2 more. Makes a square, it's 4. Easy, right? But there is no way to do that. Because the 2 is not negative. The 2 is still positive. So you cannot illustrate it. That is why this chart is the only way really to make sense with it. But some people don't get this chart. So I have another way to show it. And I'm going to do that in this quadrant up here. What if I asked you to do 2 squared divided by 2 to the 5th? What is the shortcut law there? I would do 2 to the 2 minus 5, correct? Which would be 2 to the negative 3, correct? Okay. We know that makes no sense, yes? Now, observe. What does this expression really mean? What is the numerator really? No, not 4. 2 times 2, right? Agreed? What is the denominator really? 2 times 2 times 2 times 2 times 2. Agreed? What do these 2's do? Cancel. What do these 2's do? Cancel. What's left? 1. Because 2 times 2 times 1 is still 2 times 2, yes? So I'm left with 1. What is left down here in the denominator? 2 to the 3rd. 2 to the negative 3, 2 to the negative 3 is 1 over 8. 2 to the 3rd is 1 over 8. Everybody cool? Everybody good? Okay, now I'm going to ask you to make a logical assumption. What if I were to write this? What is that? It's 2 to the positive 3. Why? What part of that makes no sense? The negative 3. Technically, this is 1 over 8, yes? Right? Which is technically 1 times, which is 1 divided by 1/8, right? Which is technically 1 times the reciprocal, 8 over 1, 1 times 8 over 1 is 8. Right? So, still, the negative exponent still bothers us. If it's in the denominator, where must it have to go? Back to the numerator. If it's in the numerator, where must it have to go? To the denominator. Is everybody good? Yes? All right. Now, I'm going to show you the biggest problem students have with this. What's that? Why? This isn't allowed, and it goes where, Hazel? And then, that's really cancel, x squared. Right? Now, is there a shortcut to get to here? Yes, because this is still an exponent law, isn't it? This is x to the negative 3 minus negative 5. Minus is what? X to the negative 3 plus 5, which is x squared. Is everybody cool? Now, I spend a lot of time with negative exponents because they mess kids up. I spend all the time with negative exponents, and every kid says, I got it, no problem. And then I show them this. Am I allowed to write that as a final answer? Why not? Because there's a negative exponent, and negative exponents don't exist. What does this need to become? 2 over x cubed. Why? The 2 isn't part of the base. What if it's that? Now what is it? 1 over bracket 2x bracket cubed. Is everybody good? All right, now listen to me. The next page has about 35 questions that are all one law. Each question requires you to apply one law to it. It should take you about 15 minutes. It should take literally 30 seconds a question to apply one law. Because the laws are what? You add the exponents, you subtract the exponents, or you multiply the exponents. Shouldn't take very long. Everybody with me? There's 33 or 34 questions. It covers pages 101 and 102. Okay? Go. I will walk around. Now, there's some bad photocopying on those. Can everybody read 25? 8, negative 2, negative 6. Any other questions from that page? Look at it. Make sure you can read the photocopying. The rest are all good? 23, 24, okay. 28 is negative 8, negative 3. Oh, and number 30 is A times A. It's not AXA. In a couple of minutes, we're going to do all of these right answers. Go. All right, ladies and gentlemen, mark along with me. Stop me only if you can't figure out why it's what it is. Okay? Everybody ready?
Yes. Are you going to explain it or just right now?
Okay. Everybody good? Everybody good? All right. Everybody good? Everybody good? I'm waiting. Now, ladies and gentlemen, because these have numbers, not variables, you would technically evaluate it. But they're gigantic numbers. And some calculator screens, I don't think, even hold 5 to the 12th. So, if you just did that, I'm happy. Okay? If you went all out and you actually did 3 to the 12th divided by 5 to the 12th, the answer is 0.00217. But again, this is what's important because we're dealing with exponent laws this unit, okay? Everybody good across 13 through 16? 16 is the question that often causes trouble. Everybody assures me they know what they're doing, and then they're like, oh, I don't get 16. Now, listen to me, please. There is a little trick to 16. You could follow the exponent laws, because over brackets, you know they multiply. So you get c to the negative 8 over d to the negative 8. Negatives aren't allowed, so you get d to the 8th over c to the 8th. There's a shortcut here. All of you should have noticed that 2 squared equaled 4 over 1, and 2 to the negative 2 equaled 1 over 4. What do you notice about those two things? They're reciprocated. So a negative exponent reciprocates the base. So you could look at this and say that negative exponent reciprocates this base to become d squared over c squared to the positive 4. It will change the exponent if you reciprocate the base. Now there's a danger there, because if there was, for example, a negative 3 there, when you reciprocate that base, does that 3 stay negative? Yes, because bases are allowed. Now here's the other mistake. Wait, here's the other mistake kids make. Let's say I had c, I'll change color. Let's say I had c squared over d to the negative 2 all to the negative 4. And I want to do and I want to do the reciprocal trick. Okay, what's the base here? C squared over d to the negative 2, all to the negative 4. When I reciprocate, only the overall exponent is changed. So this would reciprocate to d to the negative 2 over c squared, but it would be to the 4th now. Only that one will change. This one doesn't. Then it would be d to the negative 8 over c to the 8th, and then that's not allowed, so it would be 1 over c8 d8. Everybody cool? Back to Levi, yes. 15. What's the base? No. The base is n squared over m. How many of them are there? 3 of them. n. 6 n's. N to the 6th. M times m times m. M cubed. The shortcut is it multiplies. "17. Kids do wrong all the time. What's the base? 2b. 2b is squared. So it is 4b squared over 25c squared. 9a squared b squared. N6 m3. 1 over c to the 12th d to the 8th. X cubed over y cubed. X. 1 over a to the 5th. B cubed. 1 over x to the 7th, s to the 10th, and 1 over b to the 5th. Any questions? Okay. The shortcut, 5 minus 5 is 5 plus 5. Is 5 plus 5. Now, what you need to actually understand to do it right, because you're going to forget the shortcuts, that is s to the 5th, yes? Over s to the negative 5, right? So that's s. But since it's negative, where should it actually be? It needs to reciprocate, right? So these 5 would move up there. S to the 10th. Okay? And what else? This one? Okay. 24. 4 minus 3 is 1. 1 plus 2 is 3. Now, Levi, again, it makes more, you should understand why. That is B. Oh. Oh, okay. Never mind then. $17. Well, that's the one I explained. 2b, the 2 is part of the base. So the 2 is squared and the b is squared. This 1. If Now, even though I warned you, some of you still will have thought that was an x. So if you left that as an x, it's a to the 7th x. If you listened to me and I told you that was times, it's a to the 7th. M to the 8th. B to the 12th. Kids often forget the 1 that should be there. X to the 8th, y to the 5th. Why do I have to stop there? They're not the same base. Is everybody good? Jesse. Because b with the -2 has to go down, and -3 plus 2 is -1, so the a has to go down. Now listen to me. At this point is where I say, is everybody cool? And everybody goes, yeah, I got this easy. I do this in my sleep. And then I assign the next page, and everyone's like, I don't want that. So, what did I say? When we got up to exponent law 5 and 6, I said quite loudly and quite emphatically that you cannot forget exponent laws 1, 2, 3, and 4, right? It is the same thing with going forward in exponents. You cannot forget all the math that you already know. For example, if I gave you this expression, it'll come up in a second. What is that? That's 5. Why? Because 25 divided by 5 is 5. If I gave you this expression, what's that? That is 8 over 9. Why? Because you're simplifying, right? There's no exponents here. This is stuff you learned in grade 4. Do you get to forget about it? No. Okay, so we're comfortable that that is 8 over 9, right? Okay. What's that? X squared. Okay. What's that? I know it's blue. So, everybody can do those 3 things I wrote up here, right? Okay, which means you can all do this. Right? You would think it was obvious, wouldn't you, Brand? And yet, in my 20 years of teaching, every kid can do that line, and all of a sudden, no kid can do that line. Every year. It is, of course, 8x squared y cubed over 9. That, and that. I'm well aware of that. Thank you, Anu. Okay. Numbers with numbers. like letters with like letters. Okay? What if I was a real horse's patootie and I wrote it this way? I know. And I wrote it this way. Pause. And I wrote it this way. Would I fool some of you? Yes. I know I will fool some of you because I have done this and I do this every year. Some kid always puts the X's with the Y's and the X's with the Y's. No. That is incorrect. X's with X's, Y's with Y's. Wait, what if it was that? What would the answer over here be? There'd be a negative, because negative bases are okay. Go! You got 34 minutes in class. You could finish it and have no homework. 102 and 103. 103 and 104. What's happening tomorrow? Cumulative. See?
No, but we're coming in at lunch to talk to you.
Nobody came in today.
Because me and leader shipping it until tomorrow. Please, I'm student tomorrow too. Everybody, please work tomorrow. Everybody. Mr. Myers, I love you.
Yes. 103 and 104.
We will be here 5 minutes before.
Tomorrow you have this class first block.
We will be here in the morning to get help.
We'll see.
This is the neighborhood rules for everybody.
It's April 2nd.
No. Wait, did you say no?
Hmm?
Did you say no?
I sat here seasoning my spaghetti with my tears again today.
In my defense, I was going to come in today, and then I passed you. The phone's going down, and I was like, oh. So I thought you were last week.
Fine. You can have your cumulative Thursday. You're writing your cumulative Thursday.
What if there's an accidental fire?
You are writing your cumulative Thursday. I am putting it on my calendar now.